Hello everyone, my name is Tejasvi Varadaraj and today I'll be presenting my recommendation report on reducing the environmental impacts of data centers. As AI and cloud computing grow, data centers have become absolutely essential. They power our digital world from streaming and cloud storage to financial systems and modern AI models. But as they expand, their environmental footprint has grown just as fast. Data centers consume massive amounts of electricity and water, and without sustainable practices, their growth will place serious strain on both power grids and water resources. So, today, I'm going to give a short overview of the problem, walk through three major sustainable solutions, and end it with a professional recommendation on what I believe is the best way to approach this problem. So, coming to the problem, data centers worldwide consume roughly 240 to 340 terawatt hours of electricity, which makes up more than 1% of all global electricity consumption. As AI workloads increase, especially energy intensive GPU clusters, this number is expected to rise dramatically in the next decade. On top of that, many cooling systems still dependent on water even today. In places that already struggle with water scarcity, this creates a major sustainability issue. So the challenge is simple. We need data centers to keep growing, but we need them to grow sustainably. Let's come to solution one, renewable energy and smarter workload scheduling. The first major solution is integrating renewable energy into data center operations. This means shifting as much power generation as possible to cleaner sources like solar, wind, or hydro. When paired with energy storage systems such as large battery banks, data centers can maintain reliability even when renewable energy is out, like at night times. A second part of this method is scheduling workloads more intelligently. Not all computing tasks need to happen instantly. So data centers can run energy heavy tasks at times when renewable energy is most available, or even shift tasks to regions where renewable energy support is currently strong. This reduces emissions and eases the load on local grid, all while keeping performance consistent. Coming to solution two, which is improving cooling efficiency. The second solution focuses on cooling, one of the largest contributors to energy and water use in data centers. Traditional air-based cooling or evaporation systems are becoming less effective as server racks become more power dense. New cooling techniques offer much better efficiency. Liquid cooling and immersion cooling transfer heat far more effectively than air, meaning the data centers need less electricity to stay as a stable temperature. In water scarce regions, closed loop cooling systems allow facilities to recycle the same water instead of constantly evaporating the new water. Another sustainable option is waste heat reuse. Instead of releasing heat into the environment, some data centers channel it to nearby buildings for heating. This turns a waste product into a useful resource, lowering environmental impact even further. The third method is making the computing itself more efficient. Many companies are now using specialized AI accelerator chips like the TPUs, which perform way more efficiently than the traditionally used GPUs or CPUs. Coming to the software side, techniques like model quantization, pruning, and optimized compilers reduce the amount of computation required, which lowers both electricity use and heat generation. Data centers can also scale servers up or down depending on demand, shutting down idle systems to avoid wasting energy. And with modular data center designs, operators only deploy the infrastructure they truly need, keeping usage efficient and flexible. After reviewing the three of these solutions, the approach I personally recommend is a combined sustainability strategy that brings these methods together into one ongoing process. The most effective way to make data centers sustainable is not to choose one method over the other, but to integrate them in a way that supports both performance and long term environmental responsibility. So, the first step for any data center is understanding its current footprint: how much electricity it uses, how much water its cooling systems consume, how much efficiently its hardware runs. Once operators have a clear picture of this baseline, they can begin shifting their energy sources towards renewables. This can include long term clean energy contracts, on site solar installations, or energy storage systems to make renewable power more dependable. As that energy transition begins, the next part of the process is modernizing cooling. Data centers should gradually move away from water intensive, as it is, inefficient air-based systems and adopt liquid or hybrid cooling solutions. And in regions where water is scarce, closed-loop cooling should become the standard. If possible, they should also explore systems that reuse waste heat, especially in colder communities where it can meaningfully reduce heating costs. From there, the focus shifts to improving the efficiency of the computing itself. This means adopting newer hardware that delivers more performance per watt, reducing unnecessary computations through software optimization, and running workloads in a smarter way. Powering down idle servers and aligning flexible tasks with times when renewable energy is abundant. What ties all of this together is consistent monitoring. Sustainability shouldn't be treated as one time upgrade. It should be a continuous process where operators measure their progress, identify inefficiencies, and refine their strategies over time. But by combining renewable energy, efficient cooling, and compute optimization into one integrated approach, data centers can grow with rising AI demand while dramatically reducing their carbon and water footprint. In closing, data centers are critical to our digital and AI driven world, but their environmental impact cannot be ignored. The solutions I discussed, renewable power integration, advanced cooling technologies, and efficient computing, provide practical ways to reduce that impact. And by combining these methods into a single continuous sustainable strategy, data centers operators can support technological growth while also protecting our planet. Thank you.